For today's vocabulary notes, you will need in class 78. This is part 2 of standard 18, where we're looking at different segment lengths and how they interact with circles. Today's focus is all on chords. So as a reminder, a chord is a segment with both endpoints on the circle. So we're going to look at several different things that are true when chords are involved. All of the ideas today are what we call biconditional statements. And so biconditional statements are statements where two true statements are combined using the phrase if and only if. Sometimes that phrase if and only if is actually abbreviated IFF, if and only if. We've had biconditional statements throughout geometry, but we've never officially called it that. So an example of one that you've already learned about, a point is a midpoint if and only if it divides a segment into two congruent segments. Previously in the year, we've talked about conditional statements. So it would sound like if a point is a midpoint, then it divides a segment into two congruent segments. And then we would investigate the converse. So we would flip the first part of the sentence and the second part. We would say, if a point divides a segment into two congruent segments, then it is a midpoint. So a biconditional statement is something that combines a true conditional with a true converse into one sentence. So instead of saying this in both of those ways, we can combine them and just say a point is a midpoint if and only if it divides a segment into two congruent segments. So you can read the statement forwards, but you can also read the statement backwards, and it's true in both cases. So our first biconditional for today is about a relationship between arcs and chords. So arcs are congruent if and only if the chords they intersect are congruent. So in this picture, we have arc AB right here that intercepts or intersects chord AB, segment AB. And then we have chord CD over here, or arc CD over here on the other side that intercepts chord CD. And if we investigate, these two chords are exactly the same size. And so what that tells us is that the measure of arc AB, the one attached to this chord at the top, is going to be exactly equal to the measure of arc CD. And we could also work in reverse. So if we had known that these arcs were exactly the same measure, then we'd be able to mark that the chords were congruent as well. Biconditional number 2 brings in the idea of a radius. So if we have a radius that is perpendicular, we used that word yesterday with our tangents. So as a reminder, that symbol, that upside down T, it means that they intersect to form a right angle, which is what's happening here in our diagram. So if a radius or a diameter is perpendicular to a chord of a circle, if and only if it bisects the chord. Now, bisect is a vocabulary word all the way back from first quarter. Remember, that means that we're dividing something in half. So a radius is going to be perpendicular to a chord if and only if it divides that chord in half. So when we look at this radius and they're showing us it's already perpendicular, that means we can take this chord and we can show that it's bisected. So segment AB is congruent to segment CB, the two parts of that chord. If we had known these two green congruent marks were true to start with, then we would have been able to add in that right angle because we would know that radius has to be perpendicular if those two distances match. Biconditional number 3 is about what happens when chords are congruent again. So this is another way for us to know that chords are congruent. So chords will be congruent if and only if they are equidistant So that means the same distance from the center of the circle. So right here we have the circle center, and we have this little perpendicular segment marked with a tick, and then we have this little perpendicular segment marked with a tick. That is what equidistant looks like. So the distance, the fastest way to get from one point to the other is to move perpendicular, which is why these right angles are important. And then these distances are marked as being identical. And so what that tells us is that chord AB and chord CD are exactly the same distance away from the center of the circle G, which means that AB is going to be congruent as a segment to CD. Or we could say the length of segment AB is equal to the length of segment CD. Both of those communicate the same information. All right, those are our 3 biconditional statements that we can use when we're looking at the relationship between chords and other features of the circle. Bring those notes back to you when you come to class, and we will work on some examples to see how to apply those ideas to problems.